Yeah, it's a pleasure to have Dan Kolterman here. He's a biological administrator with the Florida Fish and Wildlife Conservation Commission, for some reason abbreviated FWC. Uh, but he's out of the Eustis office. He's done a lot of experiments in Lake George and the St. Johns River. And he joined FWC in 2010 and works with the Aquatic Habitat Conservation and Restoration section. And he's Dan has an extensive knowledge of restoring aquatic systems and currently working on restoring the submerged grass, referred to as eelgrass. It's Vallisneria americana in the St. Johns River. And I want to say a kudos to Dan and many of the state employees that sometimes don't get the credit. Uh, they're usually, I find FWC really dedicated staff that want to do good things for the natural resources of the state. And an example is that Dan and a couple of his colleagues installed 1,200 feet of fencing on a weekend on their own time. That was just a contribution, an unpaid contribution, and that's some of the dedication that I see in some of the FWC staff, and I think Dan illustrates that. So he's going to talk to us about eelgrass restoration in the St. Johns River.
Yeah, thanks everybody, and thanks for having me. Thanks for setting this up, Bob. Yeah. Okay, is that better? Okay. All right, so today I'm going to talk about the efforts that we've been doing on the St. Johns River to restore aquatic habitat. Like I said, my name's Dan Kolterman, and I work for FWC in the Division of Habitat and Species Conservation, and then the subsection that we work in is aquatic habitat restoration and enhancement. Um, it was earlier today. Oh, there it goes. Or did you do that? Oh, nope, it's advancing. Okay. So historically, St. Johns River is full of lush vegetation prior to 2016. It has its ebbs and flows over the years due to hurricanes, high water. You get some years with not as much coverage of vegetation. Then you have years where it's drought conditions. That vegetation pushes towards deep water. Your percent coverage throughout the system increases. Well, we had Hurricanes Matthew and Irma back to back. They both kind of approached the state a little bit differently, particularly the St. Johns River flows up through here. So, Matthew impacted the state a little bit differently than Hurricane Irma as far as wind directions go and intensities of the storm. But ultimately, the eelgrass started disappearing. A lot of vegetation started disappearing in the St. Johns following the back-to-back hurricanes. 7 years later, 2024, vegetation's really just kind of still struggling to hold on. We started doing some restoration activities in 2020, particularly in Lake George here, which is, if you look at this right photo, the big lake in the center of that picture. What we noticed in our restoration efforts initially is that the plants were germinating and wanting to grow. However, they were being significantly impacted by fish and wildlife trying to eat them, grazers, also known as herbivores. And that's kind of what we've documented over the stretch of 4 or 5 years here now. So these are called heat maps. Our agency uses sonar-based vegetative mapping techniques to go around the lakes and use sonar to pick up the vegetation, and that maps it. And these red areas are dense vegetation, ultimately topped out, lush growth. Blue is open water, no vegetation. So you can see back in 2015, Lake George had extensive amount of red. And then in 2017, following Hurricane Matthew, you start to see some impacts, particularly so on this point here. You see some impacts 2017 was Hurricane Irma. So this picture was taken right before Hurricane Irma, this 2017 image. And then 2018, you really see those impacts from the high dark water wave action that ripped up a bunch of vegetation. By 2020, essentially very little plants in the lake. Again, the same thing for Lake Monroe, a little further upstream. So 2015, before back-to-back impacts from hurricanes, this was before Matthew. This is the I-4 shoreline of Lake Monroe, very extensive vegetation. This picture again taken before Hurricane Irma shows that vegetation was impacted by Matthew, and then Irma happened. 2018 picture, you see a lot of reds here that had turned into greens and yellows and light greens. Again, similar to Lake George as far as biomass that we had lost due to those back-to-back hurricanes. Again, 2021, same story as Lake George, very few plants. So what we had started doing was building in 2020. We started, just a concept of let's build some fencing out in the lake. Let's stick some plants in it. See if we can't jumpstart the recovery of the submerged plants in the lake. So that's what we did. We built some 10 by 20-foot fences. We planted those fences. However, we saw some turtles breaking into those fences. And so when the turtles broke into the fences, this is what the plants would look like after they'd been exposed to grazing pressure, these red circles. But however, if the plants, if the fence wasn't breached and the plants were allowed to grow, they would start maturing, and you'd get, vegetation growing up to a meter tall, and it'd start, flowering and maturing. We'd see other plants start recruiting into those fences that we did not plant. And so in 2020, we'd built four of the small enclosures. We used chicken wire, which was the fencing type that we had selected to use. And with that chicken wire, you got to kind of bend it down and make an L. And it's not really sturdy stuff. So you bend it down, you kind of make an L, like a skirt almost, and you want to bury that in sand. And that kind of limits things from pushing into it. And so with the chicken wire in 2020, we had a lot of issues with that skirt lifting up, or turtles trying to get up underneath that skirt. Then that skirt would lift up and they'd gain access to those sites. And here's a turtle inside one of these fences, and here's another turtle inside the fence that it pretty much mowed down all this vegetation after it looked like this. But here's another photo of those water lilies coming inside that we did not plant. Same thing in 2021, we scaled up. We built 18 of these, and in 2021 we started putting a cross fence in the middle of it, so that if something got in one side, it didn't decimate the entire small enclosure. We grew really good looking grass inside those, had additional plants also recruiting in 2021, similar to 2020. We also started working in Silver Glen Springs. We purchased some of these cages. You see there's this lush growth inside this fence, and it won't push outside. It's just constantly being cropped off as any stitch of vegetation grows outside of it. So we had lifted that cage up, moved it over, exposed some of that grass, hung some GoPro cameras on it, and this is what came in 2 hours. All this vegetation that was exposed was gone. It only took them 2 hours just to consume all of that. And so this video is maybe like 40 seconds long or so, but you can just watch them work that grass and mow it down. And this is sped up maybe like 4x or 2x or something. So in light of all of that, we got a little bit of funding to scale up, build a little bit bigger fence enclosure. So we built a 1 acre fence at 2 spots, southwest corner of Lake George and on the west shoreline just south of Silver Glen. You can see our older fence right here from previous years. We went around that. So we built it was a 500 foot by 100 foot, 50,000 square feet, just a sliver over an acre. We built the south one with FWC staff. We had a contractor that we'd hired that was going to plant vegetation in both of them. They built this one as well. So we had two of them. They were each an acre. They were each cross fenced, and we planted one section of that, and then on the other side of this cross fence, we did not plant nothing, just as a type of control, and then another control over here, unfenced, unplanted. We had two replicates. We stuck plants in those, pretty dense, plant every square foot, so 22,000 plants in that half acre. Those fences immediately took a beating. We planted right here, one of them at this red star. You'll see that water level just climbed immediately. It went up over 3/4 of a foot or so. Extensive wave action, white capping after we'd planted. Water came back down. We planted the other one. Then wow, right back up it came. Almost a foot and a half. It came up at that point. But in light of that, we saw similar stuff to 2021. You look down this fence line, that fence is obviously working. It's protecting and allowing all these lily pads to start coming in. You can see the SAV right there, kind of that signature underneath the water. So in just a short period of time, 1 month after building and planting, start to see those lilies come in, and by middle of the growing season, winding down growing season, those plants are really maturing. This is that south fence. Here's that older one from the previous year. This fence was built right around April 1st. So this was 1 month after planting. You've seen those lily pads come in. We didn't plant those. All we planted was eelgrass in this side up here. And then the control on this one was up here was the control. So you see, just as many plants coming in this side as far as signature goes in this drone picture. And here's the cross fence, that's dark signature that you can see, that's the SAV growing underneath the water. Right on the edge of that fence line, it just stops. It's not coming outside that fence. Saw multiple species coming, naturally recruiting inside the fences. Bass fishermen started seeing the plants growing dense inside those fences. They wanted to get involved, so we actually constructed another fence that was a half acre, and we had a bunch of plants in one of our hatchery ponds that we had harvested, brought them to the lake, and we had 45 volunteers, some homeowners, mostly bass fishermen, showed up, and we planted 50,000 plants inside this fence. Moving back into Silver Glen a little bit, we're gonna talk about this shoreline fence that we had put up, and we had the contractor also plant. Here's what it looked like before we planted, and then after we had planted. This picture here shows just dense, lush growth after 180 days of being planted. The lots of other SAV, again, just like Lake George, came into these fences. We also had purchased some more of those cages that I'd shown earlier on, and we started putting those inside this yellow polygon here, about an acre and a half, and we put 148 cages in there, pretty tight. We planted those as well. And so in July, we planted those. In October, that grass was really starting to take off. Again, you'll notice, nothing growing outside the cage. So again, we exposed the grass in Silver Glen for a second time. And you'll see some turtles come in here and really graze that vegetation down. So what I did here was I hung two GoPro cameras. One I set to turn on, and GoPro are real neat. You can just tell them to turn on at a special time. So I put the cameras out at like 8 in the morning, had one turn on at 9, and had one turn on at 11. And they last about 2 hours. So I figured when the one died, the other one would turn on. And so this was the very first camera that turned on. You see the turtles come in there. They ate all the grass. This was the second camera that turned on. So in 2 hours, again, they consumed all that vegetation that was exposed to them. And I'm not sure how long this video is. It may play for another 30 seconds or so. See that largemouth bass, and there's a 10-pound largemouth bass sitting in the cage I flipped over. That's pretty good fish. So those turtles made pretty quick work of it. And if you really speed this up, you can watch that turtle just, kind of work his way into that stand of vegetation and consume those plants really, really quickly. And here comes his friend in the background making his way up to it. So during all this time, I had quite a few reports from fishermen in the upper, or I should say lower part of the St. Johns River, telling me that, hey, there's a lot of vegetation coming in. It's there. It's short. It's been like that for a year or two. So we went up there. We looked at it. Had similar grazing marks on the vegetation as what we'd been seeing in Lake George. So we decided to do a replicate study where we had 3 treatments at 4 different sites, and each of these had a control to them. What we did was we built those over existing eelgrass, and we wanted to see if grazing pressures, what's limiting the recovery of the eelgrass following those storms in a different section of the river. And so the fences were located at the Shands Bridge, at Bayard Conservation Area, at Palatka, and San Mateo. The district, Water Management District St. John's, partnered with us on this. They were going to do all the monitoring. We had the permits to do the work, so we put the fences in. And so, after 90 days, here's your control right outside, and here's what it looks like inside. So again, in the lower part of the river, the vegetation's being consumed at a pretty high rate. And so don't get too caught up in this data here, but pretty much what happened is all the sites behaved the same. The black bars are your control plots. The gray bars are your inside the fence plots. And so you'll see that the vegetation started slowly elongating, or the canopy height started increasing on all of the treatments. And so here's what it looked like inside the fence, growing grass 3/4 of a meter long, and inside the control plots, it looks like most everything else in the St. Johns River that you can look at today. So here's that second GoPro that turned on. After the turtles had eaten most of the eelgrass down, here comes the tilapia. And the tilapia started uprooting the plants and consuming the epiphytes or paraphyting off those plants, and then they would spit the plant back out. So a whole lot of good that's doing. So we kind of documented turtles, tilapia, obviously manatees. It's a combination of grazers in the system that's keeping these plants from coming back widespread. On August 4th, I had come to this south fence on Lake George again. Remember we planted this side. Well, that's this side. And
Unplanted section
on the airboat
of the south fence.
All I see is grass clippings, like somebody just mowed their yard.
Not been breached
out there. Just thinking to myself, well, that's
the
not
planted
good.
section was breached.
And I come up there, and in the
Lake George eelgrass,
open water inside this
growing
site. This
in the unplanted section.
It wasn't breached by the fish and wildlife that was consuming the plants. Cross fence had done its job. This side here looked like pretty much open water. So right now I'm walking around in here. That fence topped out vegetation. I stick the camera in the water here a couple of times, and you see underneath the water, it's just lush growth. So I'm kind of showing that there's still vegetation in this side, and in a minute here I'm gonna idle around and show you what's going on in this half that ended up being breached.
On the hunt for turtles in this side. Wow, look at all this nice Lake George grass.
100 turtles, 78 what I counted, but as I was counting them, I was throwing them out.
Popped out.
And I finally came across the hole in the fence. When I threw a turtle out, he came right back in and hit me in the feet. So I found the hole, but unfortunately I didn't have any fence with me that day to make a repair. and I had to leave it. Long story short, this half-acre
Eelgrass on the Lake George side looks really
18,
good.
20 days. They completely
Plants
consumed
are
all the plants inside that
taller than the
half
water
acre.
is because the water's down.
Here's the side that got breached. You'll see all those lily pads that you that line fence. All those lily pads were half there or barely there. They just been munched on. Second, you're gonna start seeing more turtles. There's one. Here's another one. Here's one. Here's another one. More turtles. More turtles. There's about a handful of them in this corner right here. So I get in there, I start walking around it. And look at those lily pads versus the side that I just showed you.
This was a solid field of pads.
Stems intact, and it's holding on just a little tiny piece of a pad.
All those
that's
pads
remaining.
been eaten.
Bite marks all over those plants. Same goes for the submerged plants below it.
This was solid
So I had
eelgrass.
carrying this dip net with me, and like I
This
said,
is
I
another
walked
one of
around the
blue crab.
perimeter of this fence twice,
Some crab in
and I
there,
pulled
big
out
patch
78
eels.
turtles, and I know that there was a bunch more in the middle. You know, I was just walking the fence line and throwing them out over the edge of the fence, and I come across a couple of them.
Unbelievable.
So I believe there was well more than 78 turtles in the fence. Unfortunately, like I said, I wasn't able to fix the hole, but you can tell from where I stuck that camera in on the other side of the cross fence versus this is crazy that this happened.
There's a whole line of turtles.
Just
One,
walking down the fence
two,
line.
three,
Just see them.
four of them, all Martian.
Easy spot. Netting them out. Push them over the side. This was a galvanized hardware cloth. I forgot to mention we got away from the chicken wire. That skirt lifting up on us. We found a more rigid material, you know, that kind of settled into
There's
the
about
bottom.
20 turtles in this half acre.
We moved into, you know, fencing the enclosures with that more rigid material that would.
I got two right there, two in my net. I'm gonna count them.
You wouldn't have to bury that skirt, and so that's what these fences were made out of. And unfortunately, what we found was the material started deteriorating on us after about 6 months, and it started forming holes in it. And so, like, this whole process is us trying to, you know, formulate a best management practice, or trying to find the materials that'll last the longest, because ultimately you need some longevity to these fences in order to create biomass. So after I saw those 78 turtles, I called the turtle people and I was like, hey, I think we got a problem. You know, here's that other fence on the western shore. I got the turtle people to come out. We put some holes in the fence, let them sit for 72 hours so we could allow the turtles to get in. We were going to start doing a mark recapture study, try to get a pop estimate on the number of turtles in Lake George. So in 72 hours, we got 47 turtles to come inside that fence just by putting 2 holes in it that were 6.5 feet. So they found it pretty quickly. Jumping back into Silver Glen a little bit. Hurricane Ian, Hurricane Nicole, again, 2 storms back to back in 2022. Hurricane Ian topped the fence in Silver Glen. Record water levels, you know, for the entire system. 7 days post Ian, right when the turtles were you know, starting their lunch buffet, this is what the vegetation looked like. And then 22 days, so, you know, 15 days later, in 15 days, you see all the little nubs of what remained, you know, inside this fence, and you can see all the turtles in there. So it's the turtles, I believe, is our primary, you know, herbivore in the system that's cropping off the vegetation quickly, limiting recovery. And so this is just showing those cages that we had put in and planted, and kind of the succession of those. You know, that grass is just spinning circles inside that cage. It's just trying to, you know, find sunlight, and it's just spinning circles. And that vegetation's like 5 feet tall, reach the surface of the spring. So this just goes to show that, you know, the conditions are there, the vegetation will grow as long as you can keep it protected. And again, you know, nothing grows outside the footprint of that cage. Lots of hungry mouths. So this slide just kind of mentions, you know, hurricanes are nothing new. Obviously, you know, Florida's been around for a long time. It's been impacted from hurricanes since. So, you know, what's happened now versus what storm impacts were before, and the, you know, saw recovery of vegetation in the system. And to answer that, I have you know, some thoughts in mind. Particularly, I think the drought in 2007, 2008, which is down here. You can see on this hydrograph, here's zero sea level. Here's sea level. The, you know, the water levels in that time got down here to like negative 0.5. It got really, really low. And when vegetation or when water levels get really low like that, you know, light becomes exponentially higher. You get more sunlight penetration to the sediments. You grow, you know, vegetation quicker. You know, maybe the animals can't get to that vegetation because the water levels are so low. But look what's happened since, you know, that time frame. We haven't even hardly crossed zero, or if we have, it was very short term, little tiny blips cross zero. Whereas, you know, this was a prolonged period where we saw significant lower water. And I think that's what brings the grass back. After these events, you need super low water levels, drought conditions, and we just have not seen that in the time since Hurricane Irma. So here's Hurricane Irma. It was the highest water recorded on record until Hurricane Ian came. Then it set the record. This was Faye, if you remember Faye back in 2008. This was Matthew right here. So Irma was just, you know, significantly higher, a foot higher water in the basin than Hurricane Matthew. Another possibility is the change in grazer populations. Is our populations of turtles increasing? Population of tilapia has been increasing. We've had a lack of cold weather. If you remember back in 2010, we had a lot of extensive fish kills that were happening, both freshwater fish kills, saltwater fresh kills, very cold winter. That knocks back the invasives, you know, the tilapias that can't stand cold weather. They succumb to those conditions. That's one of the herbivores out there in the system. Our agency, FWC, also restricted turtle harvest in 2008, 2012 timeframe. We'd experimented and then eventually closed the harvest of turtles. So ultimately, are we seeing more turtles nowadays versus you know, what conditions were like back when the vegetation would recover following storm events? So what we've learned and next steps, you know, lots of hungry mouths in the system, but if you protect it, it'll grow. I found this bottle in Lake George. I thought it was really neat. It had a bunch of sand in it, and sure as heck, it had a bunch of eelgrass growing in it. And the hole size, you know, typical bottle, 1/2 inch, things just couldn't get to it. You know, that picture's worth 1,000 words. Is to, you know, and that's probably the longest eelgrass growing in Lake George at that time. So ultimately, you know, we figured out that 1/2 acre, 78 turtles, they mow that down pretty quickly. We need to build biomass. We need to, you know, find that threshold or critical mass, if you will, that they will support the hungry mouths in the system. So we need to go bigger. And then in 2023, we got some funding from FWC, our habitat restoration dollars. We had a partner. FWC threw in 250,000 and our foundation matched us 100,000. And we started building bigger fences. We built 60-acre fence down here, 20-acre fence here, 10-acre fence, 10-acre fence, 5-acre fence, 10, 15 acres, 10 acres. And we had 132 acres of impact that we had covered with 7 fences. And so this year we had decided to go with a PVC coated galvanized hardware cloth to increase fence longevity, add that extra layer of protection. That PVC coating we thought may get us that year or two that we need for longevity. Turned out not to be the case. The PVC coated material pretty much disintegrated just as fast as the non-PVC coated material. You got to remember this is a pretty harsh conditions that we're trying to work in out here. This lake gets very rough, very, very quickly, very corrosive environment. So we saw some great things happen in 2023. We just had some issues with our fencing. We grew some really good grass. We grew some really good other species. The growth wasn't consistent with 2022 due to some factors such as the fence failure that I mentioned. We had differences in water levels. We noticed that when you go big and create these large fences, you have ultimately larger problems and more fencing to monitor and repair. But we also saw, an addition of muskgrass or Cara, which we didn't really see in 2020 and 2021. The Cara really started growing gangbuster in 2023. And then again, it's growing really, really rapidly right now as well. But here's the difference in water levels that I've mentioned. 2023 data is orange. 2022 data is in this purple color. So you can see in 2022, we had some pretty low water. We dropped down under 1, hung out there for a little while. During the peak of the growing season, June and July, we had about a foot, half a foot to a foot more water in the system, and that decays your light and your growth potential. So just overall changes in water levels. And here's some of the problems we had seen with the fencing and the muskgrass. This is your Cara or your muskgrass. It was growing all out here. That you kind of see some remnant pieces of it. Well, it's not really a true plant. It doesn't have true roots. It kind of has what's called a steadfast, and those any kind of wind events happen, those roots will uproot. And what we saw happen is they would consolidate up against the fence and push on the fence and break the fence. As you see here, it would get up in the fence and get caught up in the mesh, as you can see in these pictures. And then waves come and they hit that, and there's tremendous amounts of drag and damage that would occur. We had big rafts of floating vegetation that would go slamming into those fences and bend a bunch of poles over. We'd have logs that would drift in and hit the fences and put a big tear in it. And then, every time something like that happens, you got to go in and you got to remove the animals that are in there that get in, try to forage. But, just issues with material in general, with these welds breaking, that we had a lot of problems there as well. So large scale, not so great fencing. We had to switch gears again, which I'll talk about in a minute. But here's some of those big fences and some of the growth that we observed inside of those. So the plants were coming still. Moving on from that district study where we had those 3 replicates and we'd identified that, the system was having the same impacts from herbivory in the lower river is Lake George. We decided to go build a large scale test fence inside, the Palaca area of the river. So in February 2023, this is what Bob was mentioning. We had some volunteers show up. We built this fence. This was that initial photo. You can see just mainly sand. There is some vegetation down there, real short cropped off stuff that I'd shown in the past slides. That was there. We didn't plant nothing. We just simply fenced in a site that already had some small growth to it. So you see a few months later, that signature of the vegetation starting to come into that site. By September, as the growing season's starting to wind down, that grass and vegetation was topping out. It was starting to produce flowers. It was maturing, and then by 2024, essentially 1 year difference here in growth. And I don't think I have another picture of this, but the photos from May, June, and July of this year for this fence really shows this vegetation, these gaps, like the vegetation's just pushing those gaps shut. And it's really filling in area inside this fence. And really, since we had, really low water this year, all this vegetation is pushing outward towards the edge of the fence and trying to occupy deeper areas. So that's very good to see. This was part of the St. Johns River Keepers expedition. They're gathering data via line transects through here. Here's some of the data that they had gathered. As far as canopy height goes, you can see that we essentially had a meter tall grass come October, 7 months. We grew a meter tall grass. And the average is here. This is inside that fence that I just showed you. Here a little photo station for you, the day that we built it versus, a year later. You can see that the vegetation just really filling in. I really like these photos that show the inside versus outside, and you can see the vegetation. It just stops like a wall, and you wouldn't believe the amount of turtles that walk down these fences, like to the point where you can see trails. You can see their tracks and trails. It gets pretty extensive. Um, here's slightly after, shortly after we had built the fence versus 1 year later. Similar to what we saw in the replicate study with the district. The vegetation will grow as long as it's protected. We saw other species like southern naiad coming in. Here's the plants that are actually flowering, producing seed. And so we decided to go big this spring in the lower part of the river. And we utilized some volunteers. We had some money that we had stockpiled materials. We had FWC staff, put materials on boats, meet volunteers in the water. We would build these fences in pretty short order. We build a 2 acre fence in a matter of 2 hours, 3 hours. You could erect one of these. Here's some photos of the volunteers helping, and this fence right here, these pylons are these pylons. And you can see this. So this picture was taken, I believe, in April or May. I think it was 30 days after we had built this fence. You can already see that vegetation starting to come in there. And then by here's more photos roughly 30 days after building these fences. Here's another one of that Dancy Point fence I showed you a little bit ago. A little bit different angle, but you can see those gaps have really filled in, like I had mentioned. So these pictures here in this top section are from April, and in the bottom are from June. And so this fence, look at the growth that came in there, and we're just in the middle of the growing season right now. So these pictures were actually taken today. The same fences. Here's those pylons again. You can really see that vegetation's topping out. Lots of vegetation growing out here. It's all just still short and cropped. Nothing's trying to push through the fence yet. It's still getting pretty heavily grazed upon on that fence line. And then here's some on the ground photos of those same fences. So 60 to 90 days of growth. Another looking down the fence line photo showing these lilies. And here you can see topped out grass and lots of different species like southern naiad and widgeon grass or rupia. And so this is a photo of what we started with. This is what it looked like the day we built the fences. And that, grass is almost 3/4 of a meter tall in that photo. Another fence with the inside versus outside comparison. Pretty night and day. Back to Lake George, 2024. What we did this year was we refenced all that PVC coated stuff. We had to get a contractor out there to remove all the old wire and then put up new wire. And so we moved to some stainless steel fencing that we had actually trialed in 2023 that seemed to work very well. So we just settled in on stainless steel fencing for 2024 and moving forward. This photo was taken April of 2024. You can see those lily pads really starting to show their signature. Then by 3 months later, just topped out lily pads. A lot of this is that Cara, or the muskgrass that's growing. A lot of eelgrass coming in out here too, but really, really dense Cara, and that's what this all is outside the fence as well. Here's inside that same fence right now. You can see that topped out eelgrass. All these photos. Here's the widgeon grass, the rupia, and the lily pads. So this was on one side of the cross fence. And then on the other side of the cross fence, we had an issue the other day. You see these pads starting to get eaten again. We pulled 16 turtles out of that 5-acre patch. That back up. So this fence right here is 5 acres, and this one's 5 acres. So there's 10 acres here. And in this 5-acre patch, what we caught was, I think, 16 turtles, 17 turtles. They're starting to show signs of some grazing pressure. Not that it can't withhold that at this point with the dense growth in there, but you start seeing those signature signs of your grazing marks. Your plants are cropped off here, nice squared off plants versus intact tips, on the blades. So we got creative and we started doing a little bit better hunting of the animals in the fence. And we noticed that there were some gators that got in there. And so they created a hole in and allowed the turtles to get in. So we had to, get the gators out, fix the repairs, catch the turtles. It's a bit of a process. Another water level graph showing this year now in blue versus last year of 2023. And now we're back down towards normal conditions again, baseline conditions. We're starting to get below 1 foot, starting to reach some of those, half foot. But remember, back in 2008, that water level got down to negative 0.5. So we're talking, a whole nother foot and a half of water gone out of the system. And that's a big factor. So some of the research that's coming out of this is FWC has funded some internal work to do what I essentially did with exposing grass, putting cameras on it, but doing so in not just Lake George or Silver Glen, but in different parts of the river to figure out if the grazers are different in different sections of the river. Maybe we have more tilapia grazing in Lake Monroe versus more turtle grazing in Lake George, or maybe it's more manatees and blue crabs in the lower part of the river. So we're trying to figure some of that stuff out and do some different grazing studies where you establish vegetation inside of a tank and put a turtle in there and figure out exactly how much vegetation that turtle consumes on a daily basis, get some grazing rates. We also funded a turtle study with the University of Florida, where they're doing a large-scale mark recapture study, and we're going around collecting turtles out of Lake George, marking them, ultimately trying to capture as many as we can back so we can gain an insight into a population estimate. UF is also going to be using some stable isotope work to figure out, more or less what species are consuming what vegetation. So, they're going to be testing blue crabs and tilapia and turtles and trying to build a food web essentially of what herbivores are consuming what plants, and then tie that into additional grazing studies where they can ultimately give us a model that says, you know, you need to come up with 300, 400 acres of fencing so that you can, you know, get to that critical mass or that threshold, if you will. And so we have some upcoming work. Again, FWC's throwing almost $1 million of funding at this project. We got a big donation from Bass Pro Shops recently. And so we got some big money getting put into it. We got a legislative appropriation that came to us for some small cages, like I'd shown in those photos earlier, that'll go at Bayer Conservation Area. There's some partnerships still out there that we're exploring with Volusia County and Jacksport. The St. Johns River Keepers, you know, starting to get up to speed with working with homeowners and getting permits and everything that they need to start working with the waterfront owners. You know, ultimately they're a big part of the solution here, especially in certain parts of the river where, you know, it's miles of shoreline and there's just nothing but residential docks. They're going to get involved in those areas. And then obviously we're going to continue our monitoring efforts to make sure that, you know, those fences don't get breached. And if they do get breached, to get the fish and wildlife back out of those and continue always improving our techniques. And so with that, you know, what the permitters say is what goes in must come out. And so this is pulling fence down that got extensively damaged during Hurricane Ian and Nicole. So that's kind of the end of the talk. I'll let this kind of play out and answer any questions you guys have.
Thank you for the good presentation. I read that there's some areas that feel like they have too much eelgrass. Maybe they're talking about a different grass, but there are herbicides that are approved for treating those grasses. And I'm wondering if those ponds or lakes or rivers have too much, what advantage do they have over the St. John's? What are the differences?
Yeah, so I mean, obviously different lakes grow different plants at different rates. You know, it's all tied on lots of environmental factors. You know, typically, you know, submerged vegetation is not really the target. It can be the target of herbicide application, but typically it's not the target, and especially not the target in the St. Johns River. But as far as, you know, vegetation and the herbicide spraying goes, you know, we're ultimately we're not spraying eelgrass in the St. John's, but, you know, mainly floating vegetation gets treated periodically to you know, keep navigation opened. If that answers your question, sir.
Question here.
Yeah, I'm wondering if after you put all this together, you thought about subtitling this as the Turtle War on vegetation recovery. But anyway, question I have a little question and a big question. And one of them relates to the question Ellen Siegel has up there about turtles eating Cara. But what I wondered was whether or not the Cara poses a threat to the growth of the eelgrass. And the other question was, do people who are concerned the manatee problem with inability to produce enough grass in the ocean, are they paying attention to what you're doing?
Yeah, so the Cara, what I've noticed is the Cara can form some dense mats, you know, just solid carpet of Cara. What I've also noticed is the eelgrass will use the Cara as camouflage ultimately and start growing out taller than the Cara. So while the Cara can likely outcompete the eelgrass, like more so on an immediate basis, I have a feeling, you know, it kind of comes and goes on an annual basis, and what's left after that is the eelgrass that's that's come through and was actually camouflaged from the grazers and hiding inside the Cara that wasn't able to get grazed off. As far as the manatee question, um, I haven't heard I haven't really heard any complaints from any manatee folks as that what we're doing is hindering production of food for the manatee. In fact, what we're ultimately trying to do is grow biomass that will support them in the food web as well as everything else that's consuming these plants.
And just a comment, Cara is an algae, and the eelgrass is higher flowering plants that have evolved back into the below the water in the sea.
Correct.
So that's a different there. There's a question here, and then we'll take a question online.
I'm I'm wondering why these turtles are such voracious eaters. Are they being starved in there that as soon as they find it, they eat it, or is it a delicacy that they go for? What are they eating normally that they go for this with such vigor?
I think what they're doing is, over 100, 200 miles of river, potentially they're keeping vegetation at low biomass levels by just constantly cropping off new growth as it does come up, and it doesn't allow for the vegetation to come and mature. So when it does come and mature inside those fences, then obviously they serve as like a magnet, or there's a buffet in there, and so they're constantly trying to break their way in or gain access to that. And once they do get in there, they're in hog heaven.
Really eating. So your ultimate objective is to grow this for the manatees, to provide the food for
the big objective is to reestablish the fish and wildlife habitat. So these plants provide, the services, the ecosystem services that give fish and wildlife the habitat. And so objective number one is to build habitat, but within that objective, the fish and wildlife that use those plants for cover will also consume those plants. And so it's an objective to build biomass back up so we can get ahead of that grazing pressure where plants can start establishing and recovering system wide.
Okay, thank you.
And the question online, it's from Ellen Siegel that runs the climate classes here. Turtles won't eat Cara. And do we know the right proportion of turtles to eelgrass yet? And if you succeed in regrowing eelgrass fully, won't you also increase the turtle population even more? Sort of like your question. And bottom line, why does this matter? Is it all about bass fishers or water quality, quantity, distribution?
Yeah, there's lots to touch on there. Yes, the turtles will eat the Cara, I believe. Inside the fence, there's lush growth of Cara. Outside the fence, there's Cara's being eaten. So I'm not 100% sure that it's all turtles, but yes, there's grazing that does occur on the Cara. Some of the research that we have going on right now is hopefully going to highlight the proportion of, turtles per acre, or just like in a pasture, cows per acre. What's the, suggested or right stocking density or density per acre that, will handle that and allow the grass to grow without essentially taking, and mowing everything down. What's that threshold? Hopefully the research is going to touch on that. And if we succeed in growing eelgrass fully, obviously that's going to give the turtles the food and energy that they need to perpetuate their populations. And so I think that ultimately the goal is for, all species to thrive.
Dan, I'll ask a question. Can you comment on whether the population of turtles is food limited or predator limited?
Good question.
Yeah, that's a tough question, Bob.
No.
Obviously there's some top-down control. There's not a whole lot of predation on turtles, and took away one of the main predators as humans, and in human consumption or human harvest. And so that really leaves, turtles and alligators, like that top-down control of, you know, are there less bigger alligators in the system? Are there less alligators in general? If the number of big alligators goes down, you're ultimately limiting the amount of turtles being consumed by their predators. So there's some stuff to look into for that top down control for sure.
Any other questions in the room?
Well, I'm really, really interested in this.
Ellen, do you have another question?
Why does it matter? Can you answer that one?
Yeah, I was going to ask you if there is nothing vegetation left, what happens to the turtles? Do they move on somewhere else?
Well, I think they're pretty selective feeders. The turtles can eat algae. The turtles can eat, the floating mats of vegetation that run into the fences. They prefer. I think you got to think about it as, not all turtles are the same. Some people like steak. Some people like seafood. Maybe some turtles prefer eelgrass. Some turtles prefer the pads. They all disappear pretty regularly together when a breach occurs inside that fence. And I think the stable isotope analysis of what turtles are consuming what vegetation, that'll answer some of those questions, and as we move through that research.
So what did you do with the turtles that you were removing?
I just keeping them in the same system. They essentially go right back over the other side of the fence.
Ellen, did you have another question?
Yeah, I do. I'm totally in support of your project. Absolutely. I know my questions look a little pokey, and I understand why we would want mangroves and grasses on the coastline for the ecological service of building land and storage, storm surge protection, and sea level rise mitigation. Da 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 da. I don't know anything about the St. John's system at all. And I really would like to know so I can help interpret what you're doing and why it's worth all that money and all that time and all those volunteers. What are the ecological services that you are trying to do in restoring this ecosystem?
Yeah, great question. So, besides the habitat value, which it provides, critical foraging habitat, feeding habitat for many fish and wildlife, nursery habitat for, juvenile fishes. It also cleanses the water, creates better water quality,
Okay.
sequesters carbon and nutrients into the sediments. It stabilizes the sediments, having those plants and roots, and, creates ultimately it'll hold the sediments in place. If you do get big systems, wind events, it helps with sediment resuspension, traps suspended solids. It has lots and lots of ecosystem services.
Thank you. Thank you.
Habitat.
See, that makes it worth all the money and time and effort and building fences and digging them up and replanting the fences. It's quite amazing what you've done. It's very impressive.
Thank you.
Thank you.
I'm not sure that you're going to have your money's worth in success in this project. I'm thinking back on balance in nature where you have like a lot of blue crabs in some area. Blue crabs would eat periwinkles. When the local people would eat the blue crabs, then there would be more periwinkles, and then the periwinkles would eat the growing living grass rather than just the dead grass. And large patches of empty sand appeared in the marshes. So I wish you success, but I'm not optimistic.
Thank you. Yeah, Mother Nature has a way of balancing itself, which will typically take years and years, if not decades, to do. And so we're trying to recover the system in the presence of that grazing pressure, while also thinking to ourselves, is there a management need that we need to visit, like reestablishing the harvest of turtles, maybe limiting alligator hunts so that we can build back the alligator population. That it all plays into that.
Have you reconsidering having human harvesting of the turtles? But there must be a need for demand for fat, grass-fed turtles.
I think it's going to take some pretty extensive data to show that we have, an abundance of turtles to allow for our agency to even consider reopening or revisiting any harvest. But you got to start somewhere and collect data. That's kind of initially where we are right now.
I take it that there aren't studies from previous to the hurricanes to show the turtles, how many turtles per acre or stuff that you could easily compare. I mean, you're talking about turtles and harvesting them. I mean, there's another thing, and that's to remove those turtles from there, put them someplace else for a while, even if you have to feed them, and let the grasses come back, and then bring the turtles back. I know that's, slightly bizarre, but keeping those turtles out and doing it acre by acre when this is, hundreds of acres is, I commend you. I think it's wonderful, but I'm trying to think of another way to do this. And eelgrass, but, to answer Ellen's question, extremely important as it's for nursery, for fish, for all kinds of things. It's a beginning of the ecosystem in all these areas. Thank you very much.
Yeah, thank you.
Yes, I have a question that sort of goes along with one that's already been asked. For centuries and centuries, as you said, nature made its own balance between all the different factors, the predators, the food source. I know that 60 years ago, the Indian River and the St. John's were in pretty good shape. And my thought is, where did it all go downhill over a very short period of time? We've always had droughts and hurricanes and floods. How much does stormwater, sewage effluent, all the other stuff, the herbicides and pesticides and fertilizers that wash in from roads, without control of those, I don't see how that's going to be overcome. Now, I know in some counties they're removing the stormwater and they're trying to minimize the use of septic tanks, but they're still allowed. So overall, and as a native Floridian who's seen it, pardon my French, all go to hell, I wonder with those sources, how long and why aren't there big, switch gears, why aren't there bigger alligators in Lake George? So to more predators. So, I mean, we've just broken every chain of nature.
Absolutely. Yeah, a lot of what you touched on there is, urbanization, development. We're taking out our wetlands, our filters, and building homes and creating, non-pervious surfaces that now we have to have stormwater treatment areas to filter those waters. And, a lot going on there that we have, humans have changed in the state over the course of that period of time.
And I'll comment a little bit. It seems like the loss of seagrasses like in Indian River Lagoon and some of the problems in the springs it's called a bottom-up control. A lot of nutrients, and we get algae growth instead of the grass. This St. John seems like a top-down control. The water quality is okay. If you keep the grazers out, the plants grow well. So do you control alligators or turtles? Or it's a real tough management question, or can you grow enough grass to support the turtles and the grass? And that's what Dan is trying to do. Are there any other questions online? That's same question. And Dan, I think, has covered that. Any other questions?
Lots and lots of agricultural use in the upper basin, Fellsmere, Palm Bay. That area is well known for citrus production. They grow tons and tons of different vegetables as well. There's agriculture along the river, different places, cattle, farms and leases, and those animals are allowed to graze out into the river, and those certainly agricultural impacts still exist. Yeah, development's a big one.
Maybe one more question.
It's not a question. I mean, what you've been telling us is that all this urbanization occurred before those hurricanes too, and they were still doing okay. It was these drastic hurricanes, then you see this drastic change, and to come back from that is like, it's a mind-boggling thing. But one thing we could get into this, because this could be, why do we have more dangerous hurricanes, climate change, and maybe that's what this hadn't happened before and to that extent.
Yeah, and one thing I haven't really touched on is, I guess I did briefly touch on, the droughts and how it creates clearer conditions, and lower water conditions will create more light for those plants. This year is that year. We've been in a pretty good drought. We've seen low water levels. We've actually seen a lot of vegetation recover in Lake Monroe. We've seen a lot of vegetation recover in the lower part of the river. But in Lake George, it seems that we've had lots of algal blooms, which have, they come from sources of nutrients and internal loading of that lake itself. But we've had really clear water and low water in the lower river, really clear water, low water in Lake Monroe. Those population of plants really seem to be rebounding. Whereas in Lake George, where you have light now being limited by algal biomass in the water column, we're standing in a foot of water and can barely see our feet. That's a pretty big algae bloom, and so there's different factors there. Mm-hmm.
I think we all realize it's a really big problem that Dan is trying to tackle. So I think we ought to congratulate him on that and for the talk today. Thank you, Dan.
Thank you all.